In a closed and isolated system, the total momentum of the objects before a collision is equal to the total momentum of the objects after the collision.
Elastic collision. Both total momentum and total kinetic energy are conserved before and after the collision. Now, of course, this is not a perfect elastic collision, but for the sake of argument, let's imagine this example of two billiard balls colliding. We have gathered the values for the calculations, including velocity and mass, hence momentum. We can see that they result in the same momentum, since the balls have the same mass and velocity, but in opposite directions, making the total momentum of the system equal to zero. In this case, the momentum of both balls changes direction, but remains the same in magnitude, satisfying the law of conservation of momentum. Energy is also conserved, demonstrating the characteristics of an elastic collision.
Wow!
Let's check the nature of momentum. Momentum is a vector quantity in both mass and direction. Let's see what Hyein is doing here. Well, what just happened? Let's revise that. Billiards is a typical sports example that uses this nature. Skilled players will predict the ball's movement by estimating the directions and magnitude of vectors. The sum of x and y component vectors are the same, before and after the collision.
Momentum transfer. Momentum transfers from one object to another. In this case, when one ball is steered and the other ball hits it, the momentum of the moving ball is transferred to the steer ball. When the ball moves at a velocity of 6 meters per second and then stops when it comes in contact with the steer ball, we can calculate the final ball speed.
So what is the total momentum? Let's go back to the beginning. Let's first calculate P1 and P2. P1 is equal to 1.02 kilograms meter per second. P2's momentum is equal to 0 kilogram meter per second because it's still. So P initial is equal to 1.02 kilogram meter per second. P initial is equal to P final. This is because the balls have the same mass. The speed of the still ball becomes 6 meters per second.
Now, of course, we cannot ignore the friction. Friction is the resistance that one surface or object encounters when moving over another. Wow, Lina missed the shot. She's ignorant about the friction. Let's see what she's doing.
Wow!
Initially, the coefficient of friction was insufficient and the applied force was excessively strong. To mitigate this issue, we introduced a chuck to enhance the frictional interaction between two statements, thereby preventing unwanted sliding movements.